The parietal bones, all you need to know is left parietal bone, right parietal bone. And remember that the parietal bones articulate with the frontal bone in the back and the occipital bone, frontal bone in the front and the occipital bone in the back, and then the temporal bone on the sides here. So that's just each one of your parietal bones. The next bone you want to talk about is the occipital bone. So if we turn it around backwards here, you're going to see the occipital bone. Remember, it covers the back of your head, but then it goes way underneath here, and it brings in this big hole. So let's start naming some parts on this that you need to know. The first thing you want to know is this big hole. That's called the foramen magnum, and that literally translates, anytime you see the word foramen, that means hole. So this means big hole, and it's pretty obvious. So the foramen magnum, just imagine if that's sitting there. You know there's a brain in there. What comes out of the brain but the spinal cord. So as soon as this neuromaterial exits the cranial vault, you start calling it spinal cord. So from the foramen magnum on down, that's going to be spinal cord. So that's just the hole that the spinal cord enters into the brain. All right, the other thing you need to know is right on the, it's kind of, if you're looking anterior, because this is the front up here, to the foramen magnum, a little bit anterior and lateral, you're going to see two little bumps on either side of the foramen magnum. These are called the occipital condyles. Now when you see the word condyle, that means rocker. So notice they're rounded like a rocker, so that means they're going to be articulating with something and kind of rocking on it. And that's what allows your head to have this up and down yes motion, because it's going to sit on that first vertebra and it's going to be able to make this rocking motion up and down. So you have foramen magnum and then occipital condyles on either side of the foramen magnum. All right, the next bone you have is the sphenoid bone, and I like to look at that mostly from the inside, but while we've got it put together, let's see it on the outside. You're going to see the greater wings of the sphenoid bone sticking up on either side, just in front of or just anterior to the temporal bone. So that would be greater wing of the sphenoid, and that would be the greater wing of the sphenoid. But if we take it up, well, and also you can stick your fingers, if you just poke somebody straight in the eye and you poke straight back, you're touching the greater wings of the sphenoid as well. You see those little mean eye slits in there? That's part of the sphenoid bone as well. So all of that is sphenoid. Let's look inside, see if we can do it without breaking it. And on the inside, there's several parts to name. I'm going to flip it back around so that the face is this way. So this is anterior and this is posterior. And remember, you're looking at the floor of the cranial vault now. Okay? So this bone outlined right here, that is your sphenoid bone. Now, you've got the greater wings, big wings, right there. Kind of looks like a wing. And then you've got the lesser wings, these little points right here. Those are the lesser wings. So you've got greater wings of the sphenoid, and then you have lesser wings of the sphenoid. Remember, the lesser wings are going to make up that first floor. The greater wings make up the bulk of the second floor. Then in between here, you've got this little saddle-looking thing here, and that's called the sella turcica, which literally translates to Turkish saddle. This is a special little vault right there for a special organ called the pituitary gland, which is also known as a master gland, and that's going to hold the key to all your endocrine functions. So it has its own special little bony structure right there. Now that you hear about people having like pituitary tumors or brain tumors. If you're going to have a brain tumor, that's the place to have it, because if you turn it around and look, it's real easy to get up to. You can just go right up through the nasal cavity and go straight into there and get to the pituitary gland. So you don't have to damage any of the brain tissue trying to get down to that. You can just go right up through the nasal cavity and get right to it. All right, well, back to the other parts here. So we've got the greater wings right in here. You've got the lesser wings right there, these little points sticking out. That makes the lesser wings. Then you've got the sella turcica. Then you have two holes right inside the greater wings. I'm going to put one there, and then I'm going to stick another pipe cleaner through this hole. These are known as the optic foramina or optic canals. And if you turn around and look at it, you can see those are where the optic nerves travel through to the eyeballs there that are sticking in these orbits. Well, where they come in through the brain, they're going to make a cross right here. and that's known as the optic chiasma, CHISMA. That's where the optic nerves actually cross right at the base of the brain, and you'll be able to see that when we start doing the neurophysiology and neuroanatomy in a few weeks. Also, you've got sphenoidal sinuses, and remember, a sinus is just a cavity within a bone. Well, the sinuses in this particular bone are going to sit right under the sella turcica. So if you just basically took the lid off that saddle, then there would be a big open cavity in there, and that would be your sphenoidal sinuses. A lot of times you're going to have sinus headaches, and basically what you have with a sinus headache is you've got pressure building up in these cavities, and that's causing pain. So a lot of times you'll want to squeeze right between your eyes, or you want to rub right here, or rub your forehead, and that's just different sinuses filling up with pressure. And when you squeeze or push against those sinuses, that's starting to equalize the pressure, and it kind of eases the pain. So a sinus headache is nothing more than just these cavities filling up and pushing pressure outward. All right, the other bone you have in here is the ethmoid bone, and you see just the top of that. Remember, just imagine a little rectangular box just dropping down in there, and it comes out, and you can see part of it in the nasal cavity. This little plate right here is called the perpendicular plate, right inside the nasal cavity. The top part of this plate is made from the ethmoid bone. The bottom part of this plate is made from the vomer bone, which we'll get back into in just a minute. So this top part right here is from the ethmoid bone, and if you were to pinch right in between your eyes and just squeeze, you're squeezing the ethmoid bone. So you can see it outlined right in there. That's the ethmoid bone, and that's the ethmoid bone right there. So it's just that box that just kind of slips down right behind your nose. Couple features that you need to know on the ethmoid bone. First, you're going to have a little ridge up here. This is known as the crista galli, not crystal galli, but crista galli. And this little ridge, you can actually feel it. It's an attachment point for the meninges, or the connective tissue coverings around the brain. So imagine the brain kind of wrapped up in all these little different connective tissue packages. They've got to have some point to anchor onto so that the brain's not sloshing around in this cavity. And so that's what this crista galli is, that little ridge right there. That's an anchoring point for the meninges of the brain, or the connective tissue coverings of the brain. And then you've got this little area on the sides of the crista galli that has little holes in it. And that's known as the cribriform plate, not cribiform, or it's cribriform plate. And these little holes allow the nerves from the nerve fibers from the olfactory nerve, which is how you get your sense of smell, to come down here and then dip down in here, and then they're going to come out right here in the roof of the nasal cavity. So the olfactory nerve fibers will come down through these little holes in the crista galli, and then they will allow those nerve fibers to line the roof of the nasal cavity, and then that will odors will dissolve in mucus in the nasal cavity, and then that'll get picked up by those olfactory nerve fibers and be delivered back up to the brain, and you're going to say, ooh, it stinks, or whatever, oh, it smells good. All right,